Woohoo! This is Math 75 and this is 13.2, and this is the part 2 video because I got a little loquacious in the last one, and we're going to continue evaluating definite integrals. Woohoo! So the very next problem, you can see that was the previous problem we did with the triangles. It was all very exciting. Now we're going to be doing this problem. And I want to point out that at this point, when you get to calculus, the assumption is that you will know how to approach a problem from multiple directions. For example, I see a definite integral. Here's that integral sign. I've got limits, a lower bound and an upper bound on that interval. And then I've got something going on in here, whatever this is, and then a dx, which is just a reminder that we're working with x as our variable. But when I look at this, I think to myself, someone has made this very complicated by factoring, but taking the antiderivative of a factored expression is not easy. So the first thing that I'm going to go ahead and do is I'm going to go ahead and multiply this out. So in other words, I get x squared minus 5x dx in the integrand. Now, having done that, finding the antiderivative comes very quickly. X squared gets a promotion to x cubed, but I got to make sure I divide by 3. That's part of the rule. And then minus 5x, again, the 5 kind of hangs out. The x gets a promotion to squared, but then we divide by 2. Now recall that before I said you can leave c out entirely, or you can look at it from the perspective of choosing the c, the version of c that is 0, so we don't have a plus c, because we know that it's going to work out in the end. So you don't have to include the c. I'm going to put parentheses here and then a 0 to 12. Now, to be honest, not everyone includes these parentheses, so you might see just the expression, in this case the polynomial, and then this little side bracket with the 0 and the 12. So now we need to evaluate this at both values. So I've got 12 cubed over 3 minus 5 times 12 squared over 2 minus 0 cubed over 3 minus 5 times 0 squared over 2. The thing is a lot of times people say, well, if you're going to evaluate it at 0, it's just always going to be 0. And the answer is, in this case, this expression is equal to 0, but sometimes when you evaluate at 0, there's some stuff going on. It's inside of something else happens. It's hard for me to give you all the examples, but you're going to end up with something that doesn't equal 0. So always double check, even if your lower or upper limit is 0, double check that this value is 0. Okay, in this case, this is 0 cubed over 3 and 5 times 0 cubed over 0 squared over 2. That's definitely 0. And this is why I have my calculator here. I've got 12 raised to the 3rd power, 1728, divided by 3. Please go in, please. Yes, it does. So I've got 576 minus 12 times 5. 720 divided by 2, 360. So this first expression is 576 minus 360 minus, and again, I do confirm, okay, this is 0 minus 0, so we're good there. And so here I end up with, let's see, what is this, 216? You know, a lot of people can do this in their head, and I usually can, yay, but I always double check. Okay, and then this is 0, so I get 216. Woohoo! So what is the lesson from this one? Well, the lesson from this one is sometimes you might get an integrand that's been expressed in a way that's not going to make it easier for you to work out. So sometimes it's a good idea to go ahead and see what you can do to multiply out or manipulate that integrand. Again, in a full calculus class, we would have time to go over. There are so many different techniques, very cool techniques. We won't cover them here, But again, you're always welcome to ask me about them. I'm happy to give you more information. And then we come back and we're like, oh no, dun dun dun. And the reason that this is dun 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 is that this is very complicated. This problem is just a smidge harder than something that I would normally give someone who is just starting out with antiderivatives. But on the other hand, you all seem very, very smart to me. So I'm going to go ahead and let's see if we can work it out, just to give you a taste of what it looks like and what it tastes like, I guess, to try to find the antiderivative when things are getting a lot more complicated. So the first thing you might think, since the previous problem we did, we multiplied through, you might think, oh, can I multiply this all out? And the answer is no. This is a square root or a radical. This is 6x. They just bonk together. There's no way to put them together well, there is a way to put it together. Don't do it. This has actually been set up very, very carefully. Now, first thing I'm going to do is, as always, and this could always be the way you're going to stall. Stalling in math is good while your brain sort of catches up with what's going on. The first thing I'm going to do is I'm going to write that as an exponent. And I'm going to think to myself, okay, if I ignore the 6x and I think about this, so here I am thinking. I'm going to think not just out loud, but on the paper for the people who aren't watching the video and just reading the notes. I'm thinking, if I have x squared plus 9 and I raise that up, I would have to add 1, right? And then I would have to divide by 1/2 plus 1. This is using the power rule. Okay, I'm kind of thinking around, and obviously this isn't all going to work this way. So this is just a thought. This is my thought process. So this would be x squared plus 9 to the 3/2 all over 3/2. And we talked about it before, whether you believe in the boogie board amongst the sharks styrofoam concept, or you just remember that when you're dividing by a fraction, so if there's a fraction in the denominator, it flips upside down and multiplies. We get 2/3 times x squared plus 9 to the 3/2. Okay. But the problem is, but what about the 6x? It's a good question. So let's go ahead and, like I said, this is not an easy problem. So let's think about if I have x squared plus 9 to the 3/2. If I take the derivative, I'd get 3/2 on the outside, and then I would get x squared plus 9 to the 3/2 minus 1. But then I would have that inside. Remember the chain rule? And I would have the inside part, and that would be 2x. So this would be 3/2 times the quantity x squared plus 9 to the 1/2 times 2x, which if I brought this around, this would give me 3/2 times 2x times radical x squared plus 9, right? So far, so good. I know this is not an easy problem, so I apologize if you're all like, oh my goodness, what is even happening here? But hopefully parts of you are going, wait a minute, I think I could do this. The 2's would cancel, and I'd end up with 3x radical x squared plus 9. So the derivative of x squared plus 9 to the 3/2 is, let me write derivative on that. If we take the derivative of this, we end up with this. This is the derivative. Okay, so you all ready? X squared plus 9 to the 3/2 is the antiderivative of 3x times radical x squared plus 9. If this is the derivative, then this is the antiderivative of that. Kind of, sort of. So now let's look at what we've got. We have, just to write it in, because I know you can't see it because it's up there. We've got something that looks like this. Now, if I say, okay, this is from 0 to 4, right, my lower and upper limits, and then I have 2 times 3x times the quantity x squared plus 9 to the 1/2 dx, this all of this, well, not with the dx, but you know what I'm talking about, all of this matches that. And this is the antiderivative. So now, this 2 with derivatives and antiderivatives, if you have a constant multiplied, it just kind of comes, it flows in and out. So I've got a 2 that was left over, and then this all, the antiderivative, is just this. And it looks like that. So, again, to review, when we were given the 6x out in front, we were given some of the ingredients we needed to take the antiderivative, because we needed all of this to get to here. And there was just like an extra 2 just left over. Okay, let's go ahead. And I know I just said okay, like, okay, it's so basic. It's not. This is not at all necessarily simple or easy. This is probably brand new, and I would say probably just all very surprising. The good news is this that I just did, hopefully, I think I gave you 1 or 2 problems in the homework like this. Give them a try. If they don't work out so well, or even if they do and you just want to check in, you know, ask me, ask the tutors. We're happy to help you through it. Okay, now I just need to apply, this is the antiderivative. So we apply this and we look at 4 and at 0. So I've got 2 times 4 squared plus 9 to the 3/2, that I stuck in 4, minus 2 times 0 squared plus 9 to the 3/2. Now, remember in the last problem I said don't just assume that because one of the limits is 0 that you've just got 0. In this case, notice because I'm adding it to 9, it means that this doesn't just disappear. In this first case, I've got 2 times 4 squared is 16 plus 9 is 25 to the 3/2 minus 2 times 9 to the 3/2. Now we just have to remember how to do 3/2 as an exponent. And I'll remind you that this is the square root of 25 cubed. And this is the square root of 9 cubed, right? It's 1/2, then cubed. So we've got 2 times 5 cubed minus 2 times 3 cubed. So we've got 2 times 125 minus 2 times, I think that's 27. So it's 250. Oh my goodness, this is the longer part of all of this. Okay, minus 54 equals 196. Woohoo! And remember, if we had a graph of this from the last one, this would be the area under the curve, the area between the function on the graph of this one, this guy right there, and the x-axis between 0 and 4. And is it continuous? And the answer is, well, you know, sometimes there's shenanigans with the square root, but because it's x squared plus 9 and because it goes from 0 to 4 and there's nothing in the denominator, it absolutely is continuous. Woohoo! Woohoo, woohoo. Okay, so that one was the hardest one I would ever give you, and it was really hard. So be gentle with yourself when you're doing that in the homework. And then let's go on to the last problem. Yay! Yay! I'm so excited. Suppose, and it's very fun, exciting problem, suppose that money flows continuously into a slot machine at a casino at a rate of, there we go. So that's how fast money is going into this slot machine. So in other words, people are going ping, 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 and putting their money in. Or, I guess that I'm old, I'm showing my age with that, because I guess now there's not so much coins as there are just cards. You put your card in and then it just takes the money without you even noticing. It's very sneaky. So we're told that t is the time in hours, and this is over a 10-hour period from time 0, whenever you start, to time 10 hours after you start. And here the important expression is to find the total amount. If you're given a derivative and asked to find a total amount, all you do, you go from t equals 0 to 10 of a prime of t, and then this gives us a chance, if we're dealing in t's, then this is going to be dt, right? Not just dx. So find the total amount that accumulates in the machine during the 10-hour period if no money is paid out. Round to the nearest cent if necessary. Okay, so let's actually calculate this. From 0 to 10 of 2t cubed minus 5t squared plus 25 dt. And remember what we do to calculate this. I give t's promotion. So it was t to the third, now it's t to the fourth. This was t squared, it's now t cubed. This was 25, it's now 25t. And we go from 0 to 10. Now in this one, if we evaluate this when t equals 0, we will get 0. Let's see, put this in big. There you go. Minus 5 times 0 cubed over 3 plus 25 times 0. Okay, so this all is going to be 0, definitely. So let's look here. I've got, and could I have simplified the 2 and the 4? Yes. You're noticing my Achilles heel. I always forget to simplify and I just get so excited and I start plugging in numbers. Would it make more sense to simplify? Well, if it occurs to you, yes. Does it matter if you do? Nope. It'll work either way. Okay, so this 10 to the fourth times 2 is a 2 with 4 zeros. Minus 10 cubed is 1,000 instead of 10,000. So this is 5,000 thirds plus 250. And again, I don't trust my own math, so let me bring in my handy dandy calculator. 10 to the fourth times 2 divided by 4, and that gives me 5,000. And now this one's going to be a little tricky because I know this isn't going to divide easily and nicely. This is going to be 1666.66. Okay, so let me go ahead. I'm going to do this in the calculator. I'm going to add 250. Oh, Nope, because this is negative. Let me start again. 5, 1, 2, 3. There's my 5,000 minus 1666.666. Lots of them. Plus 250. And I just did the worst thing in the world by showing you doing that. But don't do as I do. Do as I say. And so we get 3583 and a bunch of 3s. Now, I happen to know that this problem doesn't want an exact answer. It wants us to round to the nearest cent. So we're going to go ahead and round to 3583.33. Woohoo. So again, let me show you this one in a better version. So the way I should have done it, because I don't know how to edit a video, I've got my 5,000. I will add my 250. So it's 5250. And then I'm going to subtract 5,000 divided by 3. I do that in the calculator. And you'll see that I got the same answer. So I don't have to retype in this value. I can use the original. And this is important because if you're not paying attention, sometimes, like what we've learned in our classes, when you're calculating mortgages, if you don't copy this down to many, many digits of accuracy, then your final calculation will be off by a little bit. So it's better to use that second method I showed you, where I actually calculate it in the calculator rather than writing it down and entering it back in. Okay, hopefully all is forgiven because we're done. Woohoo! That's it. The section is done. Congratulations. You guys are awesome and amazing and wonderful. And I'm really sorry about that one hard problem. Let me know if you would like to see it again. I'll show you other examples. I'll help you with your homework because this is not easy stuff. And, get out, get some exercise, find some flowers to pet and some dogs to sniff or vice versa. And hopefully I will see you sometime. Take care. Know that you're awesome, and math on.